Jack, got another explainer video for you.
Right on. I'm about it.
I know a lot of stuff, but I don't know everything.
Okay. All right. What are you just?
So
you're just rubbing it in my face now.
No.
Right?
So today we're going to talk about space debris, and I have like an amateur level knowledge of this. But when you want to go for the big guns, we got to go to a friend of Star Talk, Moriba Jah. Yeah. Moriba, welcome back to Star Talk.
Hey, it's beautiful to be here with both of you once again.
Moriba, you are a professor of aerospace engineering at the University of Texas at Austin, and you have special interest in space debris. And this is crap that's left over from our rocket launches, possibly even asteroids, and space debris that we didn't cause. But there's one in particular that a few weeks ago, it was reported that there was a wayward SpaceX booster that was on a collision course with the moon that's going to hit March 4th. Later intel would show maybe it's not SpaceX, but it's a booster from China. Could you update us on this?
Yeah, interestingly enough, you got amateur telescope people observing this object, and apparently at first, like you said, the hypothesis was that, yep, indeed, this is one of SpaceX's rockets, and it's on the way to the moon. It's going to crash there on March 4th. Woe is me. But then, looks like the people that discovered that this was a SpaceX rocket, turns out that they misidentified the rocket, and then they said, hey, it looks like it might be Chinese. Now, of course,
to which everybody else said, of course.
Right.
Of course.
Wait, doesn't it sound like he who smelt it dealt it? Like everyone's trying to blame it on somebody else. What's going on here?
Yeah, I know.
How could we be that uncertain?
Well, the interesting thing that I like telling people is that most of the stuff up there, because it's dead, it doesn't report its identity. So when you see a dot in the sky, there's uncertainty, there's ambiguity.
It's a bogey.
Yeah, it's a bogey.
Wow. So now what allows you to say, because clearly both rockets went up, okay? They both
a SpaceX rocket
and a Chinese rocket. They clearly both had boosters. So now how do you know that this was indeed the Chinese rocket?
I love this question. Okay, so here's the deal. Because these things are either too far or too small or whatever, whenever you see these things in a telescope image, it's a dot of light. Like, you don't see the whole thing, the size, the shape, and all this other stuff. You don't
see flags. Okay, logos.
That's a damn good telescope, though, if you do.
I'd love about a dozen of those. Yeah, but I can't find them anywhere. So here's the thing, right? So you see a dot of light, and you say, well, based on how this dot of light is behaving, I think it may have been this, that, or the other. But the thing that lets us know whether or not it's Chinese or not is sometimes you can collect reflected light or photons in different wavelengths. We call those spectral analysis. And based on how the reflected light is interacting with the material of the object, a friend of mine in Tucson said, hey, I looked at the material properties, and the material properties better match a Chinese rocket than the SpaceX rocket.
Is this matching reflection off of the metal or over the paint that's used on the fuselage?
Both.
Wow, this is like space junk CSI.
I know. Right? Forensic.
Multispectral
that's
analysis.
Right. Exactly.
Wow.
Okay, so can they implicate which launch it was?
I think that one's tougher just because you have to try to assess how does the material age in space to get some idea of the longevity, how long it's been up there. But I think that they have some rough guesses.
So does the orbit also play into the kind of investigation? Because, once something's up there, right, it has its own, unique orbit, right?
Yeah, it has its unique orbit, Chuck, but at the same time, we send satellites kind of to same places. And so the general orbital neighborhood of some of these things, they tend to be fairly consistent. So yeah,
holy
it's
crap.
tough.
Wait a minute. Okay, now you're scaring me.
It's crowded. He's saying it's
crowded. I was going to say,
That's
now
what
you
just
scare
said
me.
that.
I was about to say, and I almost said it, how much is up there? How much is up there, man?
Yeah. So let me tell you about how much is up there. So here we go. So, so right now we track about 40 or 50,000 things ranging in size from cell phone to the space station. And about 4,000 of those are things that work and everything else is garbage.
Oh God. Oh, let me just say this. Human beings, if you're in the sound of my voice, you're awful. You're just awful, okay?
We can do better.
Yeah, we could do so much better. That's crazy.
All right, so I'd expect some of those would burn up on re-entry to Earth's atmosphere. So that can't be all the ones you're talking about. Otherwise, that would have cleaned up by now.
Absolutely. And so only the ones that are in very low Earth orbit, just several hundred miles above the Earth's surface, those are the ones that eventually come in, re-enter. But the rocket bodies, they don't all burn up in the atmosphere. Some chunks of those things survive and make it all the way to the Earth's surface, and that's kind of scary.
Just a little. It kind of reminds me of why I never walk under scaffolding here in New York City.
Yeah, neither do I, Chuck.
Yeah.
It's a little paranoid, but it's true.
Yeah.
That's how I feel.
Because how do I know there's not a guy up there who's hungover or still drunk from the night before, who's just oh, my tool belt. What a shame. I just killed that guy.
Right.
Okay, so Moriba, all right, I get you that we have leftover junk in orbit, but this one is landing on the moon.
Oh.
So give me a trajectory that gets us from Earth orbit to the moon.
Yeah, so I think that once you start sending things to the geostationary belt and beyond that, depending on how the planets line up, that gravity kind of tweaking, some of these things gain enough energy to go into sufficiently longer distances or orbits that get them out to the moon. It doesn't take that much energy to go to the moon, actually.
Let me ask this for both of you. Because
Yeah.
I learned from Neil what geosynchronous orbit is, but this is the first time I've ever heard of the geostationary belt. What is that? I mean,
Yeah. Okay.
It
so
sounds like a diet.
You better tighten that geostationary belt, let me tell you.
Tighten that geostationary belt. Go
That's
ahead.
right. Look, so I think the better thing to call it is geosynchronous, because that just means that anything in this Goldilocks orbit kind of takes it about 24 hours to go around once. The geostationary means that it's geosynchronous and it's staying in the same place on the Earth's equator. So that's a tougher thing to do. Only things that you can control actively with thrusters can do that. But when things die, they stay geosynchronous, but not geostationary.
So Chuck, also for geosynchronous, you can have satellites that orbit twice per Earth rotation, or 3 times, and it's still synchronized, but at a different phase than 1-to-1. So that would still be considered synchronous, yeah. But stationary, he nailed it. It's that one little tiny belt, and it's over the equator. And more about low Earth orbit, you said a couple hundred miles up. Geostationary is how high up?
Like 36,000 kilometers.
Okay.
Okay.
Now, and how about
Okay.
for us who went to public school? You want to put that in miles? Want to put that in miles for me?
Let's just say it's over 20,000 miles. How about
Okay,
that?
there you go.
20,000 mials up. Public schools, check. So I just realized all along I've been helping you out for being a public school person,
Yes,
given all the
sir.
distances in miles. Then we get like a full-up engineer in the house, and now he don't play. He don't play.
That's right.
Okay. All right. So the energy required to get to geostationary, compared with the energy to get to the moon, you said there's not much of a difference there.
Exactly. I mean, we're talking maybe hundreds of meters per second difference of change in velocity, so it's not that much more.
So now there's not a lot of things that are going to hit the moon. Can we at least learn something from a lunar impact by watching this thing go and hit the moon?
Here's the thing, Chuck. In 2019, 4 things hit the moon. One of them was on purpose, and it wasn't news. So this is where I start scratching my head. It's like people have been doing this. Things have been impacting the moon, and now it's like a thing. But yeah, we should learn not to do that anymore.
That's what to learn.
So we've got a cottage industry among my fellow astro folk where they observe the unlit side of the moon that's facing the Earth, and they observe it every night very carefully and look for sparks of light. And these would just be meteors hitting and getting destroyed on impact. But Moriba, I had read that it's going to hit on the back side of the moon, not on the front side. So nobody's going to see this.
Right. Exactly. Unless you were like over there already.
Look at that. just like the
happen to be on
Chinese
The tardigrades are going to observe it.
shot the moon in the ass. That's terrible. That is terrible, man.
All right, so is this going to happen more often? And what's the future of this? In like a couple of minutes we got left.
Yeah, I think it just says we're littering. As we're exploring space, other celestial bodies, we're good at littering, so we're just going to keep on doing that. It's horrible.
What we need is a space Native American out there in a spacesuit, and let one single tear roll down his eye, and tell the world to stop littering space. See, I just dated myself because nobody knows what that even means.
That's from 1970, 71, Chuck. That's a long time ago.
That's a long time ago.
So there you go. Another explainer video, this one on space debris. And Chuck, you know what we're going to do from now on?
What's that?
We're going to introduce guest explainers
Okay.
for the explainer videos.
Now,
Yes.
will they be scientists, or they're just guests?
Okay, no, just random people on the street.
Exactly.
No.
And now
no,
here's
no.
George from the Bronx.
Hey, I'm from the Bronx. Okay, don't talk. So, Moriba, your field is so rich in garbage. That's
exactly why I want to do this. That's right. You had me at hello.
You are so full of trash. We want to hear more of you.
That's what we'll call the explainer. It'll be called Trash Talking with Moriba Jah.
There you go, Chuck. Chuck's got it. Okay. So we'll look forward to that, and maybe that'll be a new feature of Star Talk. Get a bunch of experts who can talk about stuff I can't, and bring them on. Yeah. And Chuck, our relationship will have to work on separation anxieties for you, okay?
Yeah, because I'm already feeling the anxiety right now, so hey.
I think you'll be fine, Chuck. So this has been yet another Star Talk explainer video. Introducing Moriba Jah as a future explainer with Chuck. Neil deGrasse Tyson here, your personal astrophysicist. Keep looking up.